Hello, welcome to the Business Transformation Podcast with your host, Sean O'Neill. Today, we are going into the second part of our Business Resiliency Engineering series. We'll be talking today about performance load testing and developer best practices. Uh, First, a little background about myself. If you haven't seen any of my other videos, I've have 28 years experience in healthcare IT. I started a long time ago on the help desk at United Healthcare. And from there, I moved into quite a few roles, starting their crisis management center, as we used to call it, set up monitoring, instrumentation, and load test teams. Done a ton of work in performance tuning around scalability and load testing, which is the topic we'll be covering today. And most importantly, I think I'm very obsessed about resiliency culture. It's the culture that you need in your organization to make a resilient business, a resilient operations, and obviously resilient technology. Uh, this is a four-part series. Hopefully you caught the first episode, which was an overview of the entire concept of business resiliency engineering. We also spent a lot of time talking about vital business functions. That topic, as you can see by the name, business functions, is all about making sure that we're looking at this topic of resiliency from a business first standpoint. Before we dig into the technology, we absolutely need to have a common vocabulary that both the technology teams and the business operations, product, sales, everybody talks about your product the same way. So if you're on the business side and you've come across this series, I would definitely recommend that you listen to that first episode. Obviously, if you're a technical person, you also have to listen to it because I'm going to be talking a lot about vital business functions. So that was covered in the first episode. Today, we are going to be talking about performance load testing, one of my favorite topics in the entire world. We'll get a little bit into developer best practices and how those two things go together, and automated testing, kind of the third step in all three of those concepts. They make a nice episode. We're going to try to keep this to around 30 minutes. The next episode will be about architecture and engineering. What are the things that you could do deep inside the architecture of your app, the way that you set up your infrastructure, in order to make it very fault tolerant and resilient for when the inevitable failures occur. And finally, the fourth episode, we'll talk about monitoring, also one of my favorite topics, monitoring best practices and alerting best practices. And most importantly, how can you automate your resiliency so that when things go wrong, instead of having a human have to go in there and kind of kick the can back over, it'll happen automagically. All right, performance load testing. Uh, so why do we do performance load test? So the most important thing and the important reason why we test our systems is so that we can, number one, identify bottlenecks and potential failure points. We don't want to be surprised in production when our system runs into a bottleneck or has a failure. What better way than a science experiment where you can simulate your failure and see how your system reacts? Are your plans adequate? Are the things that you've done good enough? Let's find out, not in production, where your customers are using your system and acting as guinea pigs. We can use robots as guinea pigs to simulate a bazillion guinea pigs hitting your website at the same time. Because why? Once again, we're going to prepare for success as we also prepare for failure. Because what does success look like for any digital business? It's your site getting swamped by enthusiastic visitors. So testing environment, great topic. In a perfect world, we have a testing environment that is identical to prod. And these days, with cloud resources, that's not as expensive as it used to be, because you can architect a on-demand environment, especially if you're using infrastructure as code, to stand up an identical environment to prod, and do all of your testing in there. Obviously, that is going to be the optimal scenario. However, once again, that might not be an option for you based on your budgetary constraints. And so with just a little bit of math, you can make a scaled environment. And I've done these quite a bit. The largest load test I ever did was during the healthcare.gov rescue. That was over 12 years ago. Literally thousands of servers that were required for the production environment. And being that this was all funded on the taxpayer dime, there was no way that we could make a 2,000 server non-prod environment to do our load testing. And so we spent the time figuring out the ratio between our expected volume, and let's make the math really simple. If it's 1 million transactions that we expect the environment to be able to handle, then you can have a 1/10 the size environment and say, well, can this environment handle 100,000 transactions? Because we've scaled it, right? Now, that scale can be really challenging, though, because not all components are scaled identically. And so, app servers or function servers these days, those are quite easy to scale out and get a gazillion of them. But things like databases, message buses, directories, definitely caches, these are all things that you, as an engineer, need to critically look at and say, am I scaling my environment so that they're as tightly coupled as possible? So once again, database. If I got a database that's in production, that's whatever, let's make the math simple, 100 CPUs, let's make another one that's 1/10 in the number of CPUs. Look at the memory, 1/10 of the memory, and down like that. And then you can have a scaled environment. And if you do use a scaled environment, you're going to identify failure patterns during your performance load test. As you ramp up your load and you start to push the upper limits, things are going to pop. Things are going to break. Look critically at those components as they're breaking and say, is this what would happen in the true scale environment, or is this a mistake that I made when I was sizing the specific component, that I made it too small as a ratio to the other components that are in the environment? Because ultimately, when you're testing, that's what you're looking for are bottlenecks. What component doesn't linearly scale? And linear scale is what you want. The idea that if I'm going to add more transactions, I can add more capacity, and that's a one-to-one up into the stratosphere. Where you identify a bottleneck is that as you're adding transactions and you're adding capacity, you lose that one-to-one and your curve starts to bend. And then at that point, no matter what amount of love or treasure or or virtual machines that you throw at your environment, you're still not able to get more throughput through the system. Then you've identified a bottleneck and you've got to dig into the why. And we'll talk a little bit about common bottleneck scenarios and how you can remediate them in a little bit. Okay, so testing for breakpoints. Oh, this is so fun. And as you can tell, I get giddy as I get giddy when I talk about this because you get to inflict damage on your site and see where it breaks. But as I point out in this first bullet point up here, begin by verifying at a low volume. So you're in a load test scenario, you got your test environment, and you got your load generation software that will be generating that load. Start small and make sure that your response time is all looking great. Then slowly ramp up your load. Most of the time, that's increasing the number of virtual users or virtual load generators, and you start to see those transactions go through the system, gradually increase that load. I know it can be really, really tough to sit there at your screen and watch it for like an hour or two as you're slowly ramping up that load. But especially the first times that you do it nice and slow so you can really see where those inflection points are. If instead you just dump a whole bunch of transactions on there and you have a failure, you're not going to know where that breakpoint is. All you know is that if you dump a bazillion transactions, it doesn't work. Doesn't give you any actionable data. So definitely ramp that up slowly. Really important, as I say right here in the middle, test all your VBFs. These are your vital business functions that we talked about in episode 1. Super critical that you're testing every one of those VBFs. And now that you have that VBS vocabulary that you can use to communicate to your business, if you dovetail your load test scenarios to a one-to-one with your VBFs, you'll be able to communicate back to your business stakeholders exactly how the site can perform. Once again, during the last episode, we used VBF example of create new user. Typical vital business function on any website is the creation of a new account. And so capture the number of account creations of that VBF so you can report back to your business stakeholder using the language that you've already agreed to. Now, test both spiky and gradual volume increases. It's really easy with these load generation tools to simply do linear increases. Every 2 minutes, add 10 more virtual users, and then just go. But a lot of times, obviously, in the real world, that's not the way that it works. So, as I said, your first test, go easy on yourself, just slowly add in users until you've identified what the upper limit is. But then go back and intentionally do silly stuff, like what's going to happen if I dump in, instead of 10 virtual users, 10, 10, 100, 10, 10, 500, right? Yeah, you really want to understand how the system will react when you have those spiky user path. Now, the example right there, simultaneous logins from thousands of users. Now, after you've kind of moved yourself along and you've been doing these tests for a while, you now have the capability to replicate scenarios from your business demands. So, for example, I have here on the screen nationwide release. So after you've established your baseline and your business stakeholders say, hey, we got this new functionality that we're going to launch, and we have every reason to believe that 10,000 users are going to be using it on day 1 of the launch because everyone's super excited. Then you can take your tests that you've already taken care of and understood your baseline and now simulate those new scenarios so that you can give your business team the confidence that they can launch that new functionality. Team involvement. A lot of times in performance load testing, it's your DevOps team or your infrastructure team that is doing the majority of the work. However, it's really important, and I cannot stress this enough. Literally, if there's one thing that you're going to take away from this entire episode today, it's get your developers involved. Especially if you have a dedicated infrastructure team or a dedicated load test team or a dedicated DevOps team that is not made up of actual developers, get them involved during the load test. Set up a Teams call or a Zoom call and have your developers that are writing the code watching how it performs under stress. It's, number one, extremely illuminating to them to give them an understanding of how their code reacts under pressure. But I feel the biggest benefit is cultural. Um, you now have this opportunity, and a typical load test could run for 4 or 5 hours, right? Yeah, 4 or 5 hours that you locked your DevOps and infrastructure team in a virtual room with the developers themselves. They might not oftentimes interact in a normal day by day business. And here's an opportunity that they can chit chat, get to know each other a little bit more, have a joke, have a shared victory when they work together to have a successful performance load test. And those interpersonal relationships and the culture that you will establish during those testing sessions is priceless. So failure simulation. Okay, we're building up to this one. We've talked on a couple of earlier slides about slowly ramping up your volume just to see how it performs under the best case scenario. Next step, now do spiky, right? Let's see what happens when we dump large amounts of users on there. Now the fun starts. You can really abuse the heck out of your infrastructure and test every possible failure scenario you can think of. So a couple examples, killing off components. Very easy nowadays in the cloud, right? Just go in there and randomly whack virtual servers. If they're in a cluster and you've done your session management correctly, your load generator software should not record any failures. Or if you do, it would be at an acceptable 0.0 whatever number of failures as you're killing off servers inside a cluster. And that's, if you have redundancy, let's make sure that the redundancy actually works. And obviously, if you have a multi-region environment and you're doing active-active, let's simulate what happens when you lose an entire region. Does the app continue to work? Are your load balancers transferring that load correctly? Are sessions maintained? And so just go nuts. Other thing would be, and we'll talk a little bit about data in a bit, but throw corrupt data at the system. Throw very, very large payloads at the system. We used to call it lobbing Volkswagens. The idea of, what is the maximum size, for example, of a JSON object that has every single possible field filled into the total character length. In a normal happy path testing, you wouldn't know what would happen. But guess what? Your customers, they're going to do stuff like that. They're going to fill up fields, all the way, maybe with, garbage characters. See how your system responds. Garbage characters, another great example. I'm sitting here, Sean O'Neill with an apostrophe. Make sure that you're testing all different types of acceptable data. And here's a great one. Got a whole slide on corrupt data streams. Intentionally throw garbage data at your system and see how if it is detected and managed as you would anticipate. You are now testing all of the data input validations that you've built into your system. Are they working as intended? Only way to really know is to throw garbage data at it. And obviously test real world scenarios. Last names with spaces in them, last names with hyphens in them, telephone numbers, without the right digits. I mean, it goes on and on and on. Um, and and really see, number one, is the bad data being blocked? Is it being logged that a bad, data was submitted? And then how is the performance? I bring this up during performance load testing because, believe it or not, sometimes bad data and the exception loops that a good developer is going to put in there to try to catch exceptions, when they're triggered in large volumes, can cause a performance spiral that will doom your site simply by having bad data being captured as intended. And once again, you want to know that that is how your site is going to react before it happens in production. Security, obviously has a component in this too. Most security exploits that are brute force exploits rely on corrupt data, large weird ass streams getting thrown at the system. So not only are you testing to make sure that your system can perform well under stress, but you're also making sure that the bad guys aren't going to use artificially generated stress to break into your site. Ah, development best practices. So we're going to shift gears for a little bit and talk about the developer role in all this. So one key thing that I'd love to point out is if you have instrumentation and monitoring for visibility in production, please put that in all of your environments. There's going to be a strong desire to not do that in order to save on licensing. Some of my favorite instrumentation vendors, who I don't need to name, you know who you are, they're not cheap. And so oftentimes it'll be like, well, I'm going to put their software in prod, and I'm going to maybe put it in my load test environment. And that's it. The developers and integration testing and dev, we don't need to put those expensive tools there. I strongly recommend that you do for these reasons. I'm going to try to convince you. Number one, if you have your performance testing tools inside your lower environments, this allows your developers on check-in to see if they've inadvertently introduced a performance problem. And if there's instrumentation that they've maybe manually put in there, they can validate that that instrumentation is working, once again, as expected. And I think most importantly, it really familiarizes your developers with the tools that are used to detect issues in prod, and they get very comfortable using them in the day-by-day check-ins and performance checks that they do in the lower environments. That way, that inevitable day when your production is down hard and your DevOps and infrastructure team are scratching their head and you need to get your rockstar developer on a bridge to try to figure out what's going wrong, this is not the first time that they've looked at your instrumentation tool, but no, they know it inside and out. They know how to use it because you've instrumented their lower environments and baked it into their daily practices. So I would definitely recommend in these lower developer environments that you're checking for response time deviation. So your typical DevOps pipeline, a developer works on their code, they check it in. As they check it in, it'll run through some automated testing. When you're doing that automated testing, make sure that you're capturing response time and failing the build, if they've exceeded, expectations, or if you want to be really fancy, if they've exceeded the baseline. Absolutely important to make sure that you push that all the way into the developer pipeline, once again, so that they're very comfortable with those types of things, and you're not letting performance defects slip into production. Now, when you do this, obviously, you need to think critically about your automated testing environment, because you're not going to have, and most likely you can't afford. I don't want to sell you short, but most likely you can't really afford a production-sized environment to be spun up on every build. Maybe you can, but if you can't, try to at least make like the data stores somewhat larger than normal, because I've seen that failure pattern happen all too often. That the automated testing, it's great, it's instrumented, and it's passing with flying colors because the database or the database stub that it's testing against only has a fraction of the data compared to production. So think critically about what you can afford. So really drilling into this automated testing. When you're doing your automated testing in general, don't just test the happy path. And once again, I've just seen this too much, right? You get your user stories from your business analyst, you put those inside your development tool, you write some code against that user story, and you write a test. And that test is a beautiful one-to-one match with the user story. It passes, checked in, and now you're going to push that to prod. Don't just do that. Think about all the possible negative use cases that you want to put in that automated test. So for example, if you've just written something that has data validation, in the XKCD comic, remember, sanitize your inputs. So if you've just put in some input sanitation, test it using a test that's going to throw garbage data at it. So that's number one. Number two, make sure that your code can handle unexpected scenarios. Number three, this is important not only to protect the business, but think of your users. So as you're writing error messages, make sure that those error messages are context aware and actionable, so that that user that just got that error message can do something with that error message useful. Like, maybe that's just call the help desk or whatever, or try again, or if they've submitted bad data, tell them what the data validation rules are so they can do it right. But write those into your tests to validate over and over again. Testing is interesting because if you ever have an issue that you've caught in prod, take the time during your root cause analysis to write a test that simulates that problem inside your build pipeline. This is now your archive, your library of everything that's ever bit you. So it's not good enough just to fix the problem, but remember how that problem was identified. And if there is a use case that you can write, do it. Put it in your automated testing pipeline. Because at the end of the day, you can have hundreds of thousands of tests. I mean, the number is, just pick a big number, right? It's okay to have plenty of negative tests. And I would say a mature shop, at least the ones that I've seen, have way more negative tests than they do happy path tests. And if you're building resilient software, super duper critical to test. Not only the happy path, but all the things that could go wrong. All right. So we've talked a lot about how to load test, and why load testing is very important to building a resilient application. And I would be remiss if I didn't at least talk a bit about some of the common pitfalls that I've seen with respect to performance. So during your load test, these are the types of things you can look out for. And we could literally speak for hours. I'll probably get together another podcast and invite some of my performance tuning gurus, and we can all talk about tales from the front lines, things that we've seen before. So this is just going to be a 5-minute overview of things that I've seen, and hopefully it's be useful to you. So first and foremost up here, the load generator bottleneck or contention. This one can be really insidious because it's actually not a performance problem. Remember earlier when I was talking about, you'll add in load, you'll scale your infrastructure, and you should see a beautiful linear trajectory. And when you hit a bottleneck, that hits a brick wall. Your performance, your response time starts to go through the roof. Your throughput takes a nosedive because nothing's getting through the system. And at that point, you start tuning and looking for all the other things that you see on the screen. But you can also have a false bottleneck if what you've done is throttled your load generator. Whether you're using something like a commercial tool like the HP Load Runner, or using an open source tool like the K6, or Postman, or you name it. If at the end of the day, though, that synthetic transaction is being generated on a virtual machine somewhere that's sitting on a physical machine that's on a virtual network and a physical network, and if you haven't scaled out your load farm adequately, what you're doing is just maxing out your load generator. So if you're using Kubernetes to spin up your load generators, obviously look very closely at your pools and make sure that you're not just hammering your load generator when you see that nosedive in throughput. But put that aside for a second. These are some other things to watch out for. So obviously, an undersized containers, undersized infrastructure in general. What you want to be able to do is add capacity, add transaction volume, and once again, see that beautiful linear one-for-one tracking. But ultimately, if you haven't laid out enough capacity, you're going to see a hotspot. You're going to see your container at some level, maxed out at memory, max out at CPU, max out at threads, max out at IO. And so, based on where your ceiling that you've hit, start increasing that. So for example, if your containers run out of memory, but still have plenty of CPU, obviously, increase the memory. Flip it around. Obviously, if you've got plenty of memory, but your CPU is getting completely maxed out, add more CPU resources. If you're in the cloud, obviously, you can grab a larger image size, based on whatever vendor you're using. So undersized infrastructure, that's the no-brainer. And hopefully all you need to do during your load test is tweak your infrastructure, adding more capacity, and achieve that beautiful linear increase. But other things that you can run into is the spin up or scale out delay. So in cloud world these days, and almost all applications these days are in the cloud, either on-prem or in the cloud, and you'll have a set capacity at the beginning, and then you'll set your scale out or scale up type parameters, especially if you're using function apps or Lambda. You're going to have multiple different instances, and as you throw more load at it, your configuration will tell the cloud to spin up more instances. Watch out for a situation where, as a new instance is added, you take a big performance hit, and then it goes away. And then another one as you're scaling. If your app is very sensitive to that, consider using already warmed instances. And once again, based on if you're in Amazon or Google or Azure, there's a ton of different ways specific to each vendor to give you warm instances or to warm up your instances before they throw load at them. So watch out for that fingerprint of a scale out problem if you have a spiky response time where you scale out, response time goes up, but then comes right back down after it's leveled out. And some of that is going to be expected. And if from a business standpoint, that's okay. If that little blip in response time literally is just a blip, you can live with it, because instances that aren't warm, they're cold start, are cheaper. And so you can save money if you don't have to go that route. Next one, connection pools and thread exhaustion. All throughout your app, you're going to have pools of connections. Hopefully you're using connection pools, and you're not making brand new fresh connections for every time you talk between resource components. So ultimately at the bottom of that, you're going to have a connection pool. Sitting behind that are going to be threads. Once again, based on whatever technology you're using. They're all very similar in this regard, with deep instrumentation. And this is where you've got to get some level of instrumentation in order to see it. If you see your response time hit that brick wall, check every single thread that you possibly can. Once again, based on the container, it may log a message to say, hey, I'm out of threads or out of connections. Especially in database connection pools, that's very commonplace. So of course, check your logs, but check your instrumentation to see if you've just done something very simple, like exhausting a connection pool. Obviously, remediate that by make it larger. But at a certain point, if you continue to make these things larger and larger, and you hit that brick wall of performance, you gotta get a little bit more creative. And we're not going to get into that. We're going to talk about just simple stuff today. But definitely, you're looking for that plateau in throughput, where the throughput is going up really, really nice, but then completely plateaus at a certain point. You're not getting any new traffic through the system. So throughput is plateaued or even starting to dip, and response time is going up. Serialization and deserialization. You can see these types of hits inside your monitoring tool, although you do have to have a deep instrumentation inside your application to see these types of things. But oftentimes, developers, as they're writing their code, they're going to be serializing or structuring objects. I mean, these days, a lot of times that is casting it into a JSON object, and then pulling it out of that JSON object into some type of string. Going back and forth, if you do that judiciously, you're not going to see a performance impact. But I've seen, time and time again, where if your application developers have written it such that you're continually serializing, deserializing, structuring, unstructuring, back and forth, many times, probably within a single transaction. Nope. See if you can stop doing that. Similar is data type transformation, pulling something into that's a binary object, maybe doing some type of a binary transformation into a string object, going back and forth between string and int. Those types of things are expensive. And if you can keep those obviously to a minimum, your application will scale and perform much better. Garbage collection. Basically, many of our technologies, I mean, obviously, if you've been around as long as me, you've spent a lot of time tuning Java apps. But ultimately, GC is something that you'll see even in, C++ applications. Ultimately, any program is going to structure memory where it can access things much faster in memory. But at a certain point, there's all the garbage that builds up that it's not needing anymore. If you have not set your garbage collection parameters optimally, you'll see a lot of time spent in GC. And based on what technology you have, you may have to set verbose GC logging as a command line parameter, or connect up a third-party open source or commercial tool that will be able to get that information from you. I'm not going to tell you how to fix a garbage collection issue. That's probably a half hour to an hour session in and of itself. But at minimum, make sure that you have instrumentation, monitoring, and logging to let you know if the reason why your throughput or response time has taken a hit is because of GC. Another leading indicator of that is CPU utilization. So if your app seems to be performing great, and then suddenly the CPU goes bonkers, maybe goes bonkers for a very short period of time, like maybe 10 seconds or a minute, and you don't have visibility in the garbage collection yet, if you see that type of pattern, oftentimes why it's chewing through the CPU is because it's doing garbage collection. Next column, IO cost. So anytime that you're accessing IO, network or disk, grabbing a file, that's expensive. And once again, either instrumentation that you'll add in to your container or looking at the container itself and the metrics that it presents. Definitely keep an eye on IO. This is a very common problem at scale, where at kind of a lower level where you're reading and writing files in the background, that's not, the hit isn't too bad. But then when you really start to throw a lot of transactions at your system, it's starting to read and write like crazy, you'll see that IO metric jump up. And obviously to remediate that is stop. Figure out how you can read and write more infrequently, maybe larger chunks at a time. So you instead of a lot of little read and writes that end up being the death by 1,000 cuts. But definitely turn on your IO instrumentation so that you can see if you run into bottlenecks there. Logging is a great example of it. It's such a common problem that I made it, it's got its own bullet point. Because oftentimes, especially in a non-prod environment where you're doing your load tests, it's okay to increase log levels so that you can have deeper visibility into how your application is performing under load. But you can also shoot yourself in the foot. Turning things all the way up to a debug level will give you a great level of visibility, but that IO can be a really big burden on your system, especially if you're using blocking IO and standard out, standard error, especially back in the Java days. There's a single IO channel for standard out by default. Obviously, there are many packages that you can use to solve that problem. But I've seen it time and time again where developers, they just turn on debug, sending everything to standard out. That write of that error message or even that debug message will grab that handle and block any other writes until it's completed. They're blocking writes. Once again, using third-party packages to solve that will help you to write through many threads simultaneously. Infrastructure imbalances or hotspots. Very common failure pattern, very easy to spot. Simply things like CPU or memory utilization of your containers. If you can look at all of your containers, they should all be running at basically the same level of CPU, IO, disk, network, number of sessions, all the different ways that you can validate that your load is evenly spread across all of your infrastructure. And if it's not, once again, the remediation is going to be very specific to your technology, but oftentimes that's inside your load balancer, your proxy, and in your stickiness settings. And so what you want is a nice load distribution. You want session stickiness for performance, but obviously manage session stickiness for resiliency to make sure that session is replicated and available somehow, so that if the container that is maintaining it crashes or goes away, that end user experience isn't completely foobarred. So a couple of things you can do in the code. And once again, this requires deep instrumentation to see the execution within your code stack. Um, Oftentimes, the vendor tools like Microsoft App Insights gives you, a rather basic and sometimes very useful view of where the time is being spent. Um, Oftentimes, however, you need to go to a commercial tool or a more powerful open source tool that can show you the lower kind of method level detail, especially when it comes to CPU utilization. So if you have an app where you hit your performance brick wall and you're seeing tons of CPU, you've ruled out garbage collection, get one of a tool that the commercial tools like Dynatrace, Datadog, New Relic, all have that capability of showing you what method, or sometimes even within a method, that CPU utilization is coming from. And oftentimes when I find this, developers are just doing super cool and amazing and very expensive calculations, over and over again, obviously looking at ways to optimize that to decrease the amount of CPU that is required to fire your function. Blocked and waiting threads. Oftentimes you'll see that either inside a log message or within your instrumentation, where you have an exclusive read or an exclusive write that is being held by a thread somewhere in your system, which blocks access from any other thread until that one completes. Couple different ways to fix blocking threads is really, first and foremost, challenge yourself and say, does this action actually require exclusive read or exclusive write? And if it doesn't, if it can handle a dirty read, so for example, if it's reading from a lookup table of business values of some sort, like SKUs, that don't often change very much, allow dirty reads. So that way you can have multiple reads from that table or that object without blocking other threads. Recursive looping. This is one where when you see it, you see it. I've seen so many applications, and I think it's getting almost worse in the JSON world, where whatever those calls may be, API calls, calls to a database, web service calls out to a strategic partner, or even your own web service or API. And instead of just going there once and getting all the information that the developer wanted, it is, well, I'm going to go get a key. Okay, once I got that key, I can do another pull, and I can do another, and I can do another, and another, and another. Those recursive loops can be a huge performance hit. They make logical sense when the developer is writing their code. It's like, well, I need this. And once I figure that out, then I can do this. And once I figure that out, I can do that. Makes logical sense. If you see inside your code that type of crazy recursive looping, go back to the drawing board, see if you can combine your calls and really limit the performance hit. Because oftentimes at the network level, a call from one system to another, especially if there's not a connection pool already established, that is a TCP handshake, a negotiation at the layer 7, level, some type of authentication, and then I'm going to get my one little piece of information and then do that all over again. So very, very common failure pattern. Also, SQL tuning. Even in the year 2025, people are still using databases. And databases can be tuned themselves at the infrastructure level with instrumentation oftentimes built into the database itself. Or once again, with a third-party tool, you can see things like index utilization. You can do some type of show plan on your query itself to see if you're actually using the indexes that you spent so much time building. Are there weird ass join problems? Oftentimes, if you do have a SQL database in your infrastructure, absolutely make sure it's instrumented during your load test so you can see how it performs under load. Session management. Um, Throughout the entire system, you're going to have sessions. It's not just users that are going to have sessions. Oftentimes, infrastructure components that are talking back and forth will have sessions. So session management, you want to be able to set up a session at the beginning of a conversation and then maintain that resiliently, so that you're not, if you can store information in that session object versus having to go retrieve it from an external system, that will definitely improve your performance. It is a form of caching, and that's my last thing I'll talk about. So caching. At the end of the day, caching is performance. That's it. All the other stuff on the screen are the things that you can do in the infrastructure, the things that you can do in your code, the things that you can do in your network. But ultimately, to get to that next level of performance, what you're doing is caching information. And that could be in a content network, a CDN. That could be in a Redis or equivalent cache somewhere. It could be cached in the session object in the user's browser. Because ultimately getting that information as close to the user as possible, or as close to the CPU function that is executing on that as possible, is the only way that you tune applications in in the year 2025, and as it has been since I've been working in this field. So lots on caching. Obviously, caching is a double-edged sword because you have to think of the information that you're grabbing. Has it changed? When it changes, do you have to invalidate the whole cache? Can you write through that cache to whatever backing store it may have, like a database or some other blob storage, where you've got a cached copy in front of it that you're always going to be accessing? It's lightning fast. But if you do have a write, can you write through that cache into its backing store and make sure that you invalidate it within the cache so that the next time you retrieve it, you're getting an up-to-date copy? Now, once again, we could spend hours talking about common performance bottlenecks, but hopefully this has been useful for you. So that's it for today's episode. I hope this has been very useful for you. Once again, today we talked about performance load testing, some development best practices, and automated testing best practices. The next episode will be about architecting for resiliency, all the things that you can do to, once again, prepare for and react to the inevitable failures that will always happen. And then finally, the fourth episode will be about monitoring and alerting. Hope to see you soon. Thank you so much. Have a great day.